Hello everyone. In this video we will see how to find eigenvalues and eigenvectors for a given matrix. First we'll take one simple 2 by 2 matrix as we are seeing here 0 minus I 0. Now for this matrix we will find out the eigenvalues and eigenvectors. For that let us consider an identity matrix of the same order of the given matrix, that is 1 0 0 1. Next we'll find out the matrix A minus lambda I is equal to, the matrix A is 0 minus I 0 minus matrix I multiplied by lambda. So what do we get if we multiply this with lambda? We'll get lambda 0 0 lambda. So when you find out the resultant matrix, you will get minus lambda minus I and minus lambda. Let us consider this matrix as equation 1. Then for finding the eigenvalues, we equate the determinant A minus lambda I to 0. Determinant of A minus lambda I to be 0. That is minus lambda minus I minus lambda. The determinant of this matrix should be equated to 0. So if you simplify this, what do you get? Lambda square, this is minus into minus will become plus, so plus I square is equal to 0. Lambda square minus 1 is equal to 0, or lambda is equal to plus or minus 1. So we have two values of lambda. These values are nothing but the eigenvalues. Now next we will try to find out eigenvectors. For that, substitute lambda values, that is the eigenvalues. Let us say first we will substitute lambda is equal to plus 1 in the matrix A minus lambda I, that is substitute in 1. So what do you get? A minus lambda I, when you substitute the lambda value, you will get minus 1 minus I minus 1. Okay. Now let the eigenvectors be x and y. Then we'll take this matrix A minus lambda I, and if x and y are the eigenvectors, multiply these two eigenvectors and equate it to 0. So if you multiply, you get two equations, minus x minus iy is equal to 0 and ix minus y is equal to 0. Let us consider x is equal to 1. If x is equal to 1, then from this equation what do you get? Minus 1 minus iy is equal to 0, minus iy is equal to 1, or y is equal to I. So this is one set of eigenvectors, that is xy is equal to 1 and I. So these are the eigenvectors for lambda is equal to 1. Next we will substitute lambda is equal to minus 1 in A minus lambda I matrix, that is in this same matrix. So for that case we will get A minus lambda I is equal to 1 minus I 1. Then again, if x and y are the eigenvectors, product will equate to 0. You will get x minus iy is equal to 0 and ix plus y is equal to 0. If x is equal to 1, then 1 minus iy is equal to 0 or iy is equal to 1, or you will get y is equal to minus I on simplification. So for lambda is equal to minus 1, the eigenvectors are 1 and minus I. Next, let us take a 3 by 3 matrix as an example for finding out the eigenvalues and eigenvectors. So this is our matrix. Then how do we start? We consider a identity matrix of the same order, then we find out lambda into I. So what will be lambda into I? This is a 3 by 3 matrix, so therefore I'll get lambda 0 0 0 lambda 0 0 0 lambda. Okay, identity matrix of order 3 by 3 multiplied by lambda. Then the matrix A minus lambda I. What do we get? We'll get minus lambda 1 0 1 minus lambda 1. This is 0, this is 1, and this is minus lambda. Then equating the determinant of A minus lambda I to 0. Minus lambda 1 0 1 minus lambda 1 0 1 minus lambda, determinant equal to 0. So here what do we get? Minus lambda into lambda square minus 1 minus 1 into minus lambda minus 0 plus 0 into 1 minus 0 is equal to 0. So here you will get minus lambda cube, this is plus lambda, this is minus into minus, you will get plus lambda, this is anyway 0 is equal to 0. If I take lambda common, I'll get minus lambda square plus 1 is equal to 0. So lambda is equal to 0 and minus lambda square is equal to minus 2, or lambda square is equal to 2 implies lambda is equal to plus or minus root 2. So the eigenvalues in this case are lambda is equal to 0 and plus or minus root 2. We'll substitute these eigenvalue values in the matrix A minus lambda I and then find out what is eigenvector. Okay, so first let us substitute lambda is equal to 0. So what do we get if we substitute lambda is equal to 0? The matrix A minus lambda I will be equal to 0 1 0, then 1 0 1 0 1 0. Okay, then to find eigenvector, let us consider that the eigenvectors are x y z 0. So what do you get if you multiply these two matrices? Y is equal to 0, then x plus z is equal to 0, and again you will get y is equal to 0. So you already got the value of y is equal to 0. If x is equal to 1, then z is equal to minus 1. So therefore the eigenvectors are, value is 1 0 minus 1. Then next we'll substitute another value of lambda, that is lambda is equal to root 2, then find out what is the another set of eigenvector. Okay, substitute lambda is equal to root 2, then our A minus lambda I matrix will be equal to minus root 2 1 0 1 minus root 2 1 then 0 1 and minus root 2. Then we'll find out eigenvector. Simply take the matrix A minus lambda I, and this is our eigenvector x, y, z equal to 0. If you multiply, you will get minus root 2x plus y is equal to 0, x minus root 2y plus z is equal to 0, then y minus root 2z is equal to 0. Then if x is equal to 1, then what do we get from this equation? Minus root 2 plus y is equal to 0, y is equal to root 2. So if y is equal to root 2, then from the last equation we will get, so here we will get root 2z is equal to root 2 or z is equal to 1. So what do we get? The xyz vector value, this is equal to 1, y is root 2 and z is 1. Then we got two values of lambda, plus or minus 2. So we will substitute now. Lambda is equal to minus root 2 in A minus lambda I. So in that case, A minus lambda I matrix will become, or A minus lambda I matrix is this one. So here if we write lambda is minus root 2, we will get root 2 1 0 1 root 2 1 0 1 and root 2. So the eigenvectors, let us say the eigenvectors are x, y, z. So upon multiplication we will get root 2x plus y is equal to 0, x plus root 2y plus z is equal to 0, y plus root 2z is equal to 0. So if x is equal to 1, then you will have from this first equation root 2 plus y is equal to 0, y is equal to minus root 2. Substitute in this last equation, we get minus root 2 plus root 2z is equal to 0, or root 2z is equal to root 2z is equal to 1. So in this case the eigenvector is 1, y is minus root 2, z is again 1. So in this way we can easily find eigenvalues and eigenvectors. Let us once revise. First we take the given matrix, then identity matrix of the same order, multiply with lambda, find what is A minus lambda I, equate the determinant A minus lambda I to 0, simplify, find the determinant, and you get the values of lambda, which are nothing but eigenvalues. Substitute these values of lambda in the matrix A minus lambda I. So this is what you will get for one of the values. Then if x, y, z are eigenvectors, then you multiply matrix A minus lambda I into the eigenvector 2 and equate it to 0. Simplify, you get the eigenvector values.